short, so you probably have some canvas time at the end. I don't know, it'll depend on how well y'all like actually do a lesson. Huh? It's what due tonight? Yesterday's? Or the Fridays? I probably put in the grades while you guys work on the next Easy Bridge. Well, that's why I mean you're not working on the next Easy Bridge till tomorrow. And you just may have some time to start ahead today. All right, look at this. They've got seats at this stadium, section 12. What pattern is happening as we increase the rows? It doubles every time? It multiplies by 3 every time? How many seats are in the first row? How many are in the second row? So what's happening every time? So have you guys ever seen these where you write stuff like 2, 5, 8, 11, 14, and then I make you fill in the blank? Does anybody know what that's called? It is a pattern. It is linear. Normally they ask you find the next number in the sequence. So it would be 17. There are 2 different kinds of sequences. So this kind of sequence where we keep adding the same thing over and over and over. Does anybody know what this is called? What kind of sequence? It's not called addition. It is addition. It's not called. It is linear, but it's not called linear sequence.
Let's start with
An A.
An asymptote.
It's not an asymptote.
That one of the other words.
It's not abstract.
what's the second letter?
Arithmetic. Artistic. Arithmetic. ASCII value.
It is arithmetic, but it's not arithmetic.
What's arithmetic?
Does anybody know what that word is? It is. It does mean math, but that's not how you say that word. It's not math. That's correct. That's an arithmetic sequence. Arithmetic sequence. So it's the exact same word as arithmetic. It means the exact same thing as arithmetic. The only difference is arithmetic is a noun, arithmetic is an adjective. So because this is an adjective explaining what kind of sequence, we pronounce it arithmetic. If it was a noun, like you do math, you do arithmetic, you say arithmetic. They mean the exact same thing. They're the exact same word, just different parts of speech. Numbers. And they want to know, is this arithmetic or is this geometric? Or neither. Well, if it was arithmetic, we look for a common difference. Which means, what's the thing that's being added or subtracted over and over and over? Well, if I go from 3 to 2, how can I get from 3 to 2? Subtract 1. If you subtract 1 again, does it give you here? So it's not arithmetic. So there is no common difference. So the next thing I'm thinking is, could this be geometric? So, okay. What did I multiply by to get from 3 to 2? 3 times 3 is 2?
Oh.
That's good. What? A 1.5? 3 times what is 2?
Yes, sir. Times 0.67.
That's rounded. Can you give me an exact form?
0.7.
No, that's not what I mean. That's rounded even more.
Oh.
How'd you get 0.67?
That's 1/3 of 3.
He's lollygagging.
Wait, what?
I'm trying to follow your logic. 1/3 of 3 is 1.
Oh.
Yeah.
Oh.
You're on the right answer. I'm just curious how you got there.
I don't know.
Okay, that's fine.
Or I mean,
Well, I said what? 3 times what is 2? Do you hear that in words? Can you make that an algebraic statement? 3 times what is 2? Well, solve for the what?
hey, buddy.
So the quicker way to do this every time is you can take this number and divide it by the one before it. And that tells you what you multiply by. So if I give you a simple one, if I go from 1 to 4 to 16, just because we know what's happening, because we can spot this one, right, times 4 times 4. If you weren't sure, take this one and divide it by this. What's 4 divided by 1?
4.
Multiplied by 4. 16 divided by 4.
4.
64 divided by 16.
4.
So you see how it tells me what's multiplying over and over. You can do the same thing here. So 2 divided by 3 is 2/3, which is 0.6 repeating forever. Or if you rounded it, 0.67. Right? But we'd rather leave that as 2/3. So now the question is 2 times 2/3 4/3? It is. So it works here. If I multiply by 2/3 again, do I get 8/9? 4/3 times 2/3. I do get 8/9. Times 2/3 again. 16 over 27. So times 2/3 works. This is called a common ratio of 2/3. I keep multiplying by 2/3 over and over. That's called my common ratio. In arithmetic sequence, the thing that we keep adding over and over and over, that's called a common difference. So that's your vocabulary. Common ratio is for geometric sequences. Common difference is for arithmetic sequences.
Arithmetic.
Can't spell. It's arithmetic, I agree. What is my common? Which one is it this time? If it's arithmetic, it's a common what? Common difference is 1.5. I keep adding 1.5. Is it arithmetic or geometric? And explain. So it's not enough to just tell me which it is. I guess how you explain it. You just tell me the common difference or the common ratio is. You said it is multiplying by 2.2. So is that arithmetic or geometric? What'd you say? I couldn't hear you. If you multiply by the same thing over and over and over, that's a geometric sequence. And how can I tell that this is a geometric sequence? Because I'm multiplying. So what do I have to say? Like, what would be my fancy? I would say there's a common ratio of 2.2. What about B? Anybody, I guess. We're just having a free-for-all. I'm adding 74, which is what kind of sequence? An arithmetic. Listen how smart you all sound. An arithmetic sequence. And because it's an arithmetic sequence, we have a common difference of 74. Whenever we start talking about geometric sequences, we can write them using a formula. This is not going to be a super big deal in your algebraic career, but if you move on to calculus, Cal 2 is very much dealing with geometric sequences and recursive functions. So I can tell probably if you just look at that formula, it looks like a lot, right? A sub n equals r times a to the n minus 1. All it's saying is if I was looking for the 10th term, so if n was 10, right, that's my 10th term. How could I find the 10th term of my sequence? Well, I could just look at the previous term. So this would be saying you put it in layman's terms? No? I don't understand. You see where I'm coming up with the 10th term? Because n is 10. Well, if n was 10, what would this be? 9. So if I'm looking for the 10th term, I could just find the 9th term and multiply that by the thing we're multiplying by over and over and over. Right? What if I want to know the 50th term? I just take the 49th term and multiply it by. That's not common sense, right? But sometimes, depending on situations, they will tell you part of this. And you have to fill in the rest. So, for example, in this one, I'm given the formula. Or not the formula. I'm given the sequence. 8, then 12, 18, 27, 40 and a half. So, what would be the recursive function? Or let's start here. What would be the common ratio? 1.5. And how did you get that? Right. Essentially, what I've already shown you how to do, they wanted you to do it formally with a formula. So like, if I were to pick out any term, say I picked out the second term. The second term would say 12 equals, common ratio is what I'm looking for, times the first term, right? The previous term. Well, how would I solve this? Divide by 8 on both sides? So this is a very mathy way to just take this term and divide by the one in front of it. Right? Which I've already shown you. It's how you find the common ratio. So they started with a very simple example. So if I had to write the recursive formula, this is what I would write. A sub n equals 1.5 times a to the n minus 1. That's it. That's my formula. All I need to find is the r.
I don't know. I think you need to do one because nobody knows what's going on. They can do it.
They can do this one? Yeah, you call that geometric sequence arithmetic. So
I tried to ask anyone if they knew what was going on.
So we got to use the geometric sequence to find a recursive formula. They gave me the formula. It's a sub n equals r times a to the n minus 1.
So you can't have a recursive formula with arithmetic. Okay.
Nope, this is only for geometric sequences. So what I really need to know is, what is my R? 0.25 or 1/4. Same thing. As soon as you know that, you plug it in. That's it. Gonna do another one like that?
Yeah, it's multiplying by
Y'all done with 7? 7's pretty amazing because it was a sub n equals 0.25 times a to the n minus 1. Everybody's okay with that? 8 should be a sub n equals 2.5. Is okay with that? Feel better about those? And that's kind of where this is going. So, for us to find the 10th term, I'm looking for the 10th term. It's going to be, the first term was 8 times r is 1.5 raised to the 10 minus 1, which I'm just going to go ahead and write 9. You okay with that? So in my calculator, I can put in 8 times 1.5 to the 9th. Does this start to look a little familiar? A times b to the, essentially, a times b to the x, right? That exponential we've been looking for.
Hey, bro, that is right.
And what did we get when we typed that in? Should have gotten approximately 307.546875. That's ugly. Okay, look at this condition. See if you can solve it. Then Annalise is going to tell us who's going to answer. Initial condition is your a sub 1. That's the first value, your initial value. So this is the geometric sequence starting at 3. What else do we know about this geometric sequence? The common ratio is 6, because this is the common ratio from that first formula, right? So my formula should look like a sub 12 equals 3 times 6 to the 11th. It's,
Don't tell us the answer, but is this supposed to be like really, really big?
it's going to be big.
Okay.
I don't know. I hadn't done it. My book doesn't tell me the answer. I'm in a student book, so. 108 million? 839,000. I'll say again. 168. So it's not. So y'all gave me bad names. 108 8391168. Should be 1,088,391,000. I knew I was to the hundreds place and you're telling me 1,100. I'm like, that ain't gonna math. Everybody good with this? That's a big number.
Yeah, it does.
It doesn't. It is not. We don't care about which value. So we just want the formula. So it's going to be f of x equals, what's my initial? 20 times 3/4 raised to the That's it. That's all I know. That's it. There's none that are exactly the same. But if I was looking for the 15th term, I would plug in 15 for x, which means I'm going to raise this to the 14th power. But good with that? So, yeah, this girl wants to come up with a mathematical formula that models her number of subscribers. She started with 5, and it's going to double each time. So, if she started with 5, we could think of 5 as the initial value, the a sub 1. And if it doubles each week, that means 2 is the R value. So if I needed an equation to model the situation, I could say f of x equals 5 times 2 raised to the right, because think about it. In her first week, I would plug in 1 for x. What's 1 minus 1? 0. What's 2 to the 0 power? 1. Because anything to the 0 power is 1. Almost anything to the 0 power is 1. Okay? And then 1 times 5 is 5. So in week 1, she had 5. No, 0 does exist. Don't say that. All right, here's my next question. How many subscribers will there be in week 9? How many subscribers can she expect in week 9? Well, we would do what? We would plug in 9 for x, which means I'm going to have to do 5 times 2 to the 8. 2, 4, 8, 16, 32, 64, 128, 256. So that'd be 2,560, 1,280. All together, everything we've been learning. So we've got the annual Town International Food Festival, and the number of people attending has been decreasing by 20% each year. And we can see last year there was 1,250 people. Any thoughts? Huh? 1250 is what I'm starting at. So that's my first value that I know. It's my a sub 1. So think back to everything we've been doing with tax and tip, with discounts, and all the sort. So, this is how many there were year 1. Year 2, I expect there to be 20% less. Which means I'm looking at how many are going to be there. So if it's 20% less, then 80% will still be there. So I need to know what's 80% of this number. So I would multiply, what's 80% as a rate? 0.8. And so the next question, I don't have room to type it. This says, how many people do we expect to be there 10 years from now?
Not many.
I know, I don't like this. This is a bad with 5. But the next question is, how many people could we expect to be there in 10 years? I would do 0.8 raised to the 9th. So 1250 times 0.8 raised to the 9th is 0.77?
Oh, it's 167.
167.7. And what are we talking about? People attending a festival. So does this make sense as my answer? No. So instead of saying 167.7, I'd say there's about 168 people.